Okay, so this is section 2.1, problem number 9, and it says let f of x be defined as this rational function we see here, and it gives us a few different limits to evaluate. Find the limit of f of x as x approaches 5, as x approaches 0, and as x approaches negative 2. Well, let's start with part A. The limit of f of x as x approaches 5. And if we plug it in, if we use direct substitution, that gives us 5 squared minus 3 times 5 minus 10 all over 5 minus 5. And this gives us 0 over 0, which we call indeterminate form. And we're going to use an algebraic technique to rewrite this rational function. So we're going to factor the numerator and the denominator. And the numerator is a quadratic. So we have x is at the front because x times x gives us x squared. Now we need two numbers that multiply to negative 10, add up to negative 3. So that's minus 5 and plus 2. And the denominator is already in simplest form. And we see these will cancel out. So if we evaluate f of 5, and I'm going to put a bar over this f because it's the modified version. It is the reduced version. And we plug 5 in, we get 5 plus 2, and we get 7. So that means there is a hole at 5 comma 7. And if there's a hole there, it means that the limit from the left and from the right will both approach 7. So that's our answer to part A then. The limit as x goes to 5 for f of x equals 7. If we go to part B and use direct substitution, the limit as x goes to 0, we get 0 squared minus 3 times 0 minus 10 over 0 minus 5. Well, this gives us negative 10 over negative 5, which is 2. There's no problem with that answer, so we're done. When dealing with rational functions, if direct substitution gives you a real answer, then that's your limit value. You're done. And let's try this for part C. The limit as x approaches negative 2 for f of x. We're going to use direct substitution and get negative 2 squared minus 3 times negative 2 minus 10 all over negative 2 minus 5. And if we simplify this, we get 4 plus 6 is 10, minus 10 is 0 over negative 7. As long as the denominator is not 0, the answer is good, and 0 over any number is 0, so the limit equals 0. Right? So that's it for problem number 9. We had to use factoring to evaluate the limit in part A, and part B and part C, direct substitution got the answer for us.